Okay, so good afternoon to all of you. Here I have shared the screen. The screen is visible, right? Screen is visible there? Okay. And
Yes, ma'am.
okay, yes, thank you for your reply. So here we need to start our fifth experiment. Experiment covered. Okay, we need to cover here fourth experiment. So first of all, we will talk about this 2-hour agenda. Okay, what will be explaining from my side, and then after what is expectation from your side. Everything will be discussed. Fine. So here let's start with I will explain you. First of all, I will explain you the theory behind our fifth experiment. Then I will explain you how you will prepare your lab manual. Once all this thing will be explained, then you will take out your pen and book. You will prepare something. I will tell you what you need to prepare in your book. Everything will be prepared. Then students are present here. They will take our digital kit. They will take the IC. Okay, they will take IC from here, and they will make the implementation or realization or whatever the circuit connection. They can do it, and then they will verify with their book work. So in this way, we will cover all these 2 hours. Okay. So first of all, I will explain you all this thing. Then your task will be started. Okay. So let's start with over here. I'm going to make it highlighted. This is your fifth experiment. Okay, I'm going to read the title for you. Construction of half adder and full adder as well as half subtractor and full subtractor using logic gates and verify its operation. This thing we need to cover. This is our title. Okay. Now to understand this title, we will understand first of all what is half adder and full adder, half subtractor and full subtractor. And to understand its operation with practical, we will implement this circuit using digital trainer IC kit. So here, first of all, we will try to understand what is the meaning of half adder and full adder. Okay. So now can anyone give me the reply? What is the meaning of adder? And which kind of circuit it can be used? Title is there. Is it readable properly? Okay. Half adder. Now forget about half right now. What is the meaning of adder? And which kind of circuit it can use? Adder, it's a kind of circuit that can add something. That is called adder. So we need to make this circuit. Half adder means, let's say I want to make a 2-bit. 1 bit from one number, second bit from second number. Let's say right now everything is in binary. Let's say I want to add 0 with 1, 1 bit. Okay, so half adder circuit can be used 0 plus 1. So we need to design this circuit. Okay, whenever I will give 0 and 1, I can get correct output using this circuit. So we need to design it. So first of all, we need to define how many inputs and outputs are required. From here, if let's say you are having one adder circuit, how many input it can have? One input. How many output it can have? So over here I need to add this 0, means one terminal would be there at the input side that can accept this 1 bit. Second terminal of this circuit can accept 1. Then this circuit will add 0 and 1 and can generate the output. So here I have taken 0 and 1. Sometime, let's say some user wants to add 1 and 1. Then this terminal of input will accept 1. Second terminal of input will accept 1. Now what is output? 1 plus 1, binary I am talking about. 1 plus 1, binary addition, first shifter. 0 and carry is 1. Okay, so all this thing can be generated by means of this circuit. So this circuit will be having 2 input and 2 output. 2 input and 2 output. Now based on whatever, see, in theory, I am talking about theory. Total 10 to 20 circuit are there that needs to be designed. We will start in our next upcoming lecture to design combinational circuits. Second part of second chapter. At that time, you need to design 10 to 20 circuits. So same thing will be applied. First of all, you will define the problem. So I have defined it. Half adder, it's a kind of circuit that can add some bit. Based on this definition, I will decide number of input and output. So adder, this kind of adder will accept 2 input and can generate 2 output. Next, block diagram. So block diagram, 2 input and 2 output. Here you need to design this internal circuit. This is your aim. Internal circuit should be designed. This is our aim. But to design it, I should know some function. I should know some equation. Okay. How I can make equation? Using truth table. So first of all, I need to make truth table. So how truth table is made? Can anyone tell me? Here, first of all, 2 input. So how many combination are there? 4. How many output column are there? Output column 2. Output column 2. So here, input and output column are drawn. This is truth table. Because 2 input, how many combination are there? 0, 0, 0, 1, 1, 0 and 1. Now look at the sum column. Over here, what will be generated? That we need to write. So if my input is 0, 0, 0 plus 0, output will be, sum will be 0 and carry will not be generated. So whatever circuit that we are going to design under this box, that will display sum is 0 and output is, means carry out is 0. Let's say some other user comes and he or she will enter 0, 1. A is 0, B is, so this circuit will produce a right output. So which kind of output should be generated? Sum should be 1, carry out 0. Likewise 1, 0 and 1, 1. Sum 0, carry out 1. So using this explanation, we have defined here the table. Okay. Once truth table has been generated or designed, then what is our next aim? We need to solve output column. Okay. So if complex truth table is there, in our today's lecture, we have seen one topic. First of all, we have made truth table. From truth table, we have made K-map from today's lecture only. And from K-map, we got one equation. But here, K-map is required. It's very much simple truth table. Is K-map required to solve this? No, it's very simple. Generally, we will use K-map to solve complex or long truth table. But here, K-map is not required. We can easily see by means of observation. We can easily get equation. So can anyone observe it properly? What is sum column? Sorry? Yes, addition, but which kind of operation is there? So whenever both the inputs are equal, output is 0. See your observation. Whenever both the inputs are different, output is, which gate is it represents? X OR gate. X OR gate. Now observe carry out column. Which gate it represents? It is AND gate. So by using our observation, we can make equation. Otherwise, if your truth table is tough, then you will make K-map and you will get equation. But here K-map is not required. By means of our observation, we found that S is equal to A XOR B and C out is equal to A and B. So we have drawn here two inputs are there. They are XOR together using this gate and they are ended using this gate. So these circuits are available inside this box. Okay. Whenever I will give 0, 0. Okay, one animation is given using which you can easily understand. So whenever I will give 0, 0, then this XOR gate will produce 0 and this AND gate will produce 0. So yes, summation should be 0, 0. If someone let's say entered 0, 1, then output will be 1. PPT is not changing. Okay. There it is not changed. That's why I'm asking. Okay. So what you will do? What is your role? Okay. First of all, listen. After completing of all this explanation, you will take your book. You will make truth table, and you will draw this diagram in your book. Then you will take digital kit, you will implement this circuit using this IC and you will verify this truth table with your output that you need to do. Okay. So this is about half adder. Now moving forward to full adder. Right now, no, it should not be done right now. You will be told. But this is a work for you from this much of topic. That is what I say. Now next is full adder. Now suppose in real life, let's say you are having one calculator. Will you enter only 0 and 1? What you will enter? 256 plus 788 in decimal. Okay. Someone let's say, I don't know what is 12 plus 1, let's say. Okay, so I will enter 12, then I will enter 1, I will enter plus sign means operation. So calculator will give me 30. Okay. So in real life, we will see in real life, user will not enter only one bit. User wants some complex answer, I mean some complex addition. Okay. So let's say, now consider I want to add 12 plus, not 8, but 12 plus 9, let's say. Okay, I want to add this. So in the calculator, I will place 12, then I will place plus sign, then I will place 9. Inside this calculator, it will be first of all converted to binary. So what is the binary of 12? 1, 1, 0, 0. What is the equivalent of 9? 1, 0, 0, 1. Actually, if I want to explain it, I need to change. Let's say 13 plus 9. So 1, 1, 0, 1, 1, 0, 0, 1. So let's start addition. So obviously, one half adder will be there. One half adder will be there. That will add this 1 and 1. Inside the calculator, let's say one half adder is there. One half adder can add this to 1. Means number of bit is equal to number of adder. Okay. So here total 4 adder are implemented in calculator. Let's say 1, 1. So half adder will generate sum as a 0. And carry should be forwarded here. Okay. So it should be connected to next half adder. Fine. So next half adder, one input will be connected to this 0. Second input will be connected to this 0 because half adder is having only two input terminal. where this one will be connected. Third bit, which is coming from previous addition, where it should be connected. So this is the limitation of half adder. So in this case, in real life, generally designer used full adder, because full adder, which is having 3 input terminal and 2 output terminal, because this is a limitation of half adder. Half adder can add only 2 bits. But whenever carry is generated and it is forwarded to next bit, answer will be wrong if we are using half adder, because it is having only 2 input terminal where this one should be connected. So we should have full adder. So what is full adder? Full adder will add one bit from A, one bit from B. Let's say this is A and this is B number. So one bit from A, second bit from B, and third bit from previous summation K. So full adder is a kind of circuit that can add 3 bits at a time. That's why it is having 3 inputs and 2. Clear now why 3 input, 2 output. Application is in calculator, in ALU, adder can be used. Wherever addition is there, it can be done with the help of adder. So block diagram. Just a second. Block diagram. So 3 input, A, B, C in, 2 output, sum and K. So what I told you, once it is not in mute. Okay. So once block diagram will be covered, then what we will do? We will make the truth table. So now how truth table will be made? 3 input, that's why 8 combination. So 3 input, that's why 8 combination are written. Then you need to write this sum column and then C out column. So 0, 0, 0. Sum is 0, carry 0. 0 plus 0 plus 1. Sum is 1, carry is 0. 0 plus 1 plus 1. Sum is 0, carry is 1. So in this manner, sum and C out column is made. Now, either you can make KML or still using the truth table, I can make the equation. In today's lecture, we have seen how equation is made from truth table. So first of all, let's say I want to make the equation for sum column. So look at 1. 1 is given here. So A bar, B bar, C in. Next, A bar, B, C in bar. Likewise, A, B bar and A, B, C. This is the equation. Now if I want to simplify it, what I will do? So here, first of all, you can take something as an common. So here C in and C in. Here C in bar. So here C in bar is taken as common and C in is taken. Are you getting the point? C in and C in. And here C in bar and C in bar. So they are term considered as a common term. So you will get AB bar or A bar B, AB or A bar B bar. Now can anyone tell me what this equation represents? AB bar, A bar B. It represents XOR gate. If I will make truth table from XOR gate, and this is the truth table, 0, 1, 1, make equation A bar B, A, B bar. So this represents XOR gate and this represents X NOR gate. So let's take I am just writing X in place of this XOR gate. X C in bar, and here it is X NOR gate. C in. Again, what this equation represents? I have considered one symbol in place of A, B bar or A bar, B. I have put X. You can take Z, you can take any symbol. So again, what is this a representation of this? X, X or C in. This is normal term, complemented term and normal term. So whenever this kind of equation is there, I can put XO. So now replace this X with its equivalent value, what we have considered. We have considered X is equal to A XOR B. And again here it is A XOR C in. So our final equation is A XOR B XOR C in. I would like to repeat once. Here, first of all, C in is taken common. So we got this equation. Now what is AB bar and A bar B? XOR. So we have put A XOR B, C in dash as it is. What is AB? A dash B dash X NOR. Okay, but X NOR can be written XOR bar. X NOR bar. Okay, now you may leave. So here final equation is A XOR B XOR C in. Did you get the equation? Excuse me. Did you get the equation? You will explain this equation to him. Later on, you will be given time. So final equation is A XOR B XOR C in. Now next you need to solve the equation for C out column. So same thing. First of all, you will consider 1. Then you will make equation A bar, B, C. Second one is here. So what is equation? A, B bar, C. Next one is here. So what is your equation? A, B, C bar. Last one, A, B, C in. So in this way, first of all, the equation is made. Once equation is made, then you just need to solve it out. How it is being solved? Again, C in is taken outside. C in. It's taken outside. So A bar B, A B bar. It is A XOR B. And here A B is taken common, first of all. So inside the bracket, C in bar or C in equal to 1. So that's why AB is written here. So final equation S and C. We got these two equations. Now what is our next step from equation? We need to draw the figure. So you know how figure is being drawn. This is the figure. What figure represents? So first of all, it is A XOR B. Here we will connect C in. So final output will be A XOR B XOR C in. So this is drawn. Now if you want to draw this thing, A XOR B is ready-made here. So I can take one terminal for A XOR B. It will be ended with C in. So this A XOR B and it is connected with C in. Here what will be the output? A XOR B into C in. So this is over. This much of portion is over. Now what you need to do? A and B. So A and B. A and B. Now they both should be OR together. The final equation is this. So after completing all this thing, you will write the truth table, equation and this figure in your book. You will implement this circuit using digital kit and you will verify your output with the truth table. This is your aim. Now here what is your observation? Full adder is a combination of two half adder and one OR gate. Two half adder and one OR gate. You can be asked one MCQ like true or false. Full adder is a combination of two half adder and one AND gate. Because yes, false, because it is combination of two half adder and one OR gate. Okay, so here this much of thing you will do, but before it I will explain you the lab manual. So here lab manual is opened. You need to write the apparatus. Okay, whatever I see that you are going to use, wires, digital kit, everything should be written here. You will write some brief theory of half adder, full adder. And once you will implement half adder and full adder, believe me, automatically you can implement half subtractor and full subtractor. Once you implement it, okay, by your own self, you will implement it. But first of all, you need to understand the circuit. Automatically, half subtractor will be implemented by you. So all this brief theory will be written in theory portion. Then you will be having half adder, some space is given. So what I told you, you need to make a book work for truth table and circuit. Photo of your book work should be pasted here. One space is given under half adder. You will paste your book photo, book work photo. Generally, student will take printout of lab menu, but right now it is not possible. If you have printout, then you will draw the half adder circuit in lab manual in place of book. Right now printout is not available, so you will draw in book, then you will paste the photo. Then same, truth table, remove this truth table from here. Okay, and you will paste your made truth table in your book. Everything should be your work. Fine, don't enter manually this truth table. Take photo from your book and you will paste here. Same way for half subtractor, book work photo should be pasted here. Same way full adder, you can make space based on your photo. And full subtractor. Then you are given procedure. So you will write procedure that you can type. It's okay with this. Test simulation result here. Now here, offline student can take photo of your connected circuit from kit. They can paste here. Online student will have an online simulation and they will paste their work here. Up to procedure, all things are same for online and offline student. But here, as per your result, you can make your connection photo. Online student can make their simulation photo. Conclusion, pre-lab and post-lab, it will be done from virtual lab. This is same for all students. And then some MCQs are given. In this way, you will prepare your lab. So that's it from my side. Now your work is being started. Everything should be prepared in note, book, then you will connect the circuit. Then you will verify. Now, doubt. Yes, what was your doubt? Yes, Shakti Raj, everything should be prepared. It is also for you. You are not prohibited. Everything should be prepared. Online student and offline student will prepare all these things. Because you also need to take screenshot of your book work. Shakti Raj, are you there? Okay, so online student will prepare everything in your book, means truth table, equation and circuit diagram, half header and full header. Then you will open virtual lab, because in virtual kit XORICE is not available right now. So you will open the virtual lab. I have pasted the link there in the chat box. Okay, where you will find here half adder, full adder, second experiment. You will open it. You will go to simulator. You will go to half adder, and here two simulator are given. Online student, I am explaining you. Okay, everything will be checked using this simulation. If you will find any doubt, please let me know. And you need to take a screenshot of your work. How screenshot will be written? Let's say simulator 1. Power turned on. Let's say 0, 0. So right now, none of the LED glow. So you will click on add. Give me, let me explain this. So you will add, so here automatically your work is ready. Then 0, 1. So here you can say sum is 1, carry is 0. Click on add. Okay. So in this way everything will be verified and you will take a screenshot of this work. Online student, and then you need to paste this screenshot under the title simulation result screenshot. Here. You will paste it here. And your bookwork photo will be pasted here under the title half header, full header, half subtractor, full subtractor. Here your bookwork should be pasted. And here your simulation result will be pasted. Here. Now you got it. So simulation 1, simulation 2. Simulation 2. So here you will enter manually the bit at the input and output. And then you will click on check. Right now I haven't entered anything. Let's say 0, 1, my input. So sum will be 1, carry will be 0. I will click on check. So right now it is written here correct. So you will enter all these things and you will take this kind of screenshot. Okay. So you will paste this screenshot in your lab manual. Later on, you will attempt pre-test and post-test. This is your whole, right now you are having 1 hour, your 1 hour work. You will be asked after 10 minutes about your work. Is there any query, anyone? Here sometime a full header from virtual lab sometime gives error. So here I am going to paste one more link for full header only. So use this two link. Half header, pre-lab and post-lab lecture, post-lab MCQ will be covered from virtual lab, and full header will be covered with this circuitverse.org simulator. Is there any doubt now, anyone? You will be asked to share your screen, or either you can be asked any question after 10 minutes. So you can start your work.